So we'd like to graph our quadratic function and make sure that we have at least 5 accurate points depicted on the graph. And our function is written as f of x equals the quantity x plus 1 squared minus 5. You always want to take a look at your functions and ask yourself what form is it written in, because that will tell you the most to get started about your graph. So our options for the equations are standard form, factored form, and the third option is referred to as vertex form / transformation form. As of right now, we can see that how it's written, this is going to be your vertex transformation form. So we know how it's moved from the original function of x squared. So again, thinking about comparing it to your function x squared, we can see that we have a 1 being added to our x, and so we're talking about our horizontal shift here. So when we see that plus 1, we have to think the inverse is happening, so we're moving it to the left 1 unit. And we also see the subtraction of 5 back here, which means we are lowering our function by 5 units. That's a vertical shift down 5 units. So now that we have the transformations, there are 2 methods that you can use to talk about graphing your function. And so we'll go back to the first method that we were shown from day 2 using your transformation table. So again, now that we know that we're talking about going to the left 1 unit, you have to ask yourself, is that an input change or an output change? Left is horizontal. Horizontal would be input changing, so that's going to change our inputs, our x values, and vertical shifting down, that's an output change. Those are your output values. So we think back to that original x squared input-output table, and then we apply the transformations to that. We can make the adjustments in the inputs and outputs, and what remains will be the coordinates of the points on our transformed function. So again, for the outputs, we're taking away 5 from each of those, and the inputs, we're just taking away 1 to move it to the left 1 unit. So again, our graph is going to be generated with the coordinates of -4, 4, -3, 1, -2, -4, -1, -5, 0, -4, 1, -1, and 2, 4. And we can plot those points and see our function being developed. Again, that's how we started working with our transformation table on day 2. Now, we have our other method that's kind of using the same idea, just a little bit more condensed. Since we know the transformation, and we always have the starting point, kind of the turning point of your quadratic function at 0, 0, your vertex, we could take the vertex by looking at our function. Again, our original vertex was at 0, 0. Now we can see it's at -1, -5. We could use that vertex then as the starting point in our table, the center of our table, and build our table around it by selecting inputs to the left and to the right of that vertex x value. So let's take a look at that second option. So again, we talked about the transformations. We know the new location of the vertex. We said -1, -5. And we can build the table around it. So we want to pick input values to the left of -1 and input values to the right of 1. Take those, substitute them into the function, and see what we get out. Those will develop points that we could plot to build our quadratic function. So this is a potential list of inputs that we could test to substitute into our function and see what we get out. Again, it's your choice. For this one in particular, we probably want to use 0 as an input because that will help us find our y-intercept. So once we have the corresponding outputs, we can start building our parabola. And again, because we see that input of 0, we know we're talking about our y-intercept being at 0, -4. We also saw that in our previous table with the transformations. And we connect our points to make our continuous function. At this point, we could continue on. We can see we do have x-intercepts on our graph, but they're not grid points. So we're going to hold off on those and keep going with what we do see from our equation and from our graph. And so the next thing I would go on to would be talking about the axis of symmetry, because we know that goes through our vertex and it's going to use that same input value. So our axis of symmetry is going to be x equals -1. We also can talk about the concavity, the direction our parabola, our quadratic function opens, and we can see that it's opening up. Again, that goes back to the a value being positive. Remember, our a value is right here, and that's a 1. We also can talk about the domain and range, domain being the set of all the inputs being used. And as we look at our function, we can see there are no restrictions on the inputs. So we can have -infinity to +infinity. And range, talking about the outputs. And again, everything is from lowest, highest. So for our range, how low is it going? Well, we do have a cutoff there at -5. So we can't use, excuse me, anything below -5, but everything from -5 and above is being used as an output. So we're going to show that we're using all the values greater than or equal to -5. So we've got our bracket, -5 to +infinity. So again, we're at the same point as before, talking about, we still need to know these x-intercepts. They exist. Again, they're not just grid points. So how could we find them? Well, like we did in our previous warm-up example, we could use our systems of equations knowledge, saying we have a second function of y equals 0, because x-intercepts do have outputs of 0, and find the intersection of these two functions. So if you go to your graphing calculator, you go to Desmos, we'll put our first function here, the quantity of x plus 1 squared minus 5 into y1, and then we'll put 0 in for y2 and see where they meet. So we're entering our functions into y1 and y2. Again, we can have a standard window, so you can press the zoom 6 or adjust it manually. That will set you from -10 to 10 for both x and y counting by ones. Then to find the intersections, you can press second trace, option 5. Use your left or right arrows to get close to one of the intersection points and press enter 3 times. You repeat that step again to find the other x-intercept, so second trace, option 5 for intersection, hitting enter 3 times as well. We'll definitely be rounding, so if we round to the nearest 10th, what will we end up with? Well, we can see one's happening at about -3.20, and the other one is occurring at about 1.20. So again, because we're rounding, if you're typing things into class kick, we can say about, and then write the coordinates for each x-intercept.